Good morning, good afternoon, good evening to wherever you are in the world. My name is Carsten Roensdorf. I look after spatial data infrastructures at Ordnance Survey here in the UK. And I'm going to talk about geospatial data and services today. And we will see as the webinar unfolds how these are coming together in a location-enabled platform. So I'm going to go through 5 elements today. So first of all, I will be talking about the evolving need for location data. Then I will focus in on the notion of smart cities and answer the question of why smart is important for geospatial. I'm going to talk about data sharing and interoperability from a geospatial perspective, shed some light on foundation datasets and foundation services, and then bring it all together in terms of a location-enabled data platform. For each of these five items, I'm going to kind of draw out 3 particular points in a summary slide as we go along. So let's get started. So from a geospatial data perspective, I think a lot of us started with, well, a paper map. So you see a particular nice one here in the county of Kent in the UK. And over the years, we went through a process in which the analog maps were digitized, and you see here, a digitized spaghetti data set. At some point, they were object built. We added other data layers, such as addresses, the routing network, as well as contextual orthophoto data. So this is how geospatial data basically evolved over the last few decades. On another slide, what you can see here is from an Ordnance Survey perspective, how this basically went on in Great Britain, where we started surveying in the late 18th century, integrated data into a national projection system, digitized the data, object build it, and then to the right end we did a lot of kind of background work on componentization over the last few years. So one of the obvious questions is, well, what's next? How is geospatial data going to develop in the future? So I would hope what we can all agree on is that location information, geospatial information, is really a vital component for every nation and for a host of different use cases. And on this slide, you see quite a number of use cases ranging from traffic to emergency management to energy to transport and planning, as well as repairing incidents. So geospatial data is a very versatile thing, and getting access to data by geospatial services is more important than ever. I think there's a general goal of what we're trying to achieve here, and that is to create a virtual world, a virtual model of the real world that we can then use to do certain things in the virtual world before we implement them in the real world. So there's this interplay between the virtual model and the real world that is going to become more important as we're moving forward. Going into some use cases. So this is a clipping from from the Times newspaper from a couple of months ago. Britain to boost the internet revolution, and you see, well, a number of kind of big ticket items there: the internet revolution, 5G, the next generation mobile telephone networks, lots of investments in the hundreds of thousands of pounds or the billions of pounds, well, and the name Ordnance Survey. And what this article goes into is that mapping information, location information, will be particularly important to plan these next generation 5G technologies and networks going forward. Another example is transportation. So with devices everywhere, cars being connected, we are going to move, or we think that we're going to see a lot of changes in the field of transportation over the next few years. And that can go into the areas of delivery of goods, delivery or transportation of people, the coordination of transport to basically ease congestion and provide a better experience for people to travel around the cities or between cities, between countries even. And obviously it's easy to see that the position of, well, the road infrastructure, the transport infrastructure, the individual vehicles will play an important role, and it will play an important role not only in terms of a static maps of where the roads are, but in real time of where individuals' vehicles are and how they communicate with each other. From an information integration perspective, what we should be able to do is to integrate data sets such as highway data with other data coming from public services, such as how are these services used in a street, which people have bus passes, what effect does that have on the utilization of these services? How can we make services available or better usable for physically challenged people, for instance? So before going into smart cities in a bit more detail, there are a number of application areas that we looked at which we think are going to be important. One is the built environment, where data integration in the built environment is currently still quite a challenge, particularly to integrate data that comes out of the life cycle of infrastructure and buildings as they are created together with geospatial information. Transport we already talked about. Energy, particularly from a smart grid, smart metering perspective. Integration of solar power, for instance, will become an important factor. Emergency and resilience is something that I think many countries are looking into at this point in time, to create data readily available to deal with emergencies should they happen. Environmental analysis has been in the GIS domain for a long period of time. I think we're going to see this growing, and there's a particular area in terms of social data, social experience, which is perhaps a little bit underdeveloped at this stage. But we'll come back to that when I talk about our involvement in the OGC Future Cities pilot a little bit later on. So I think there's an evolving need for location data, and the way that the data together with services are used probably falls into three different areas. The first of them is scenario planning. So having data at your fingertips, it should be possible to model, for instance, the effect that a policy might have in the future. And with scenario planning, I think we're going to move away from maybe evaluating 1 or 2 or 3 scenarios into a much larger number of scenarios going forward. And with that, we are kind of moving into a big data world. Simulation is the next one, and perhaps the planning of 5G networks and the asset utilization that goes with that, because it is expected that a much larger amount of antennas will actually be needed, is a good example for simulation. If you go into the transport domain, then we deal with something which we can call supply-demand optimization. So how can we use kind of a congested road network much more efficiently in order to make traffic flow happen at all times of the day and reduce congestion? So moving into smart cities. So what is smart? What does that actually mean? We see a definition here of smart cities, which is really all about connected and integrated system, data-driven decision-making, supply-demand optimization, with a goal to make the city more efficient, more sustainable, and really to achieve better outcomes for the people who live, work, and visit the city. There is this perhaps slightly overstated fact that 2/3 of the world's population is going to live in urban areas by 2050. The reason why I'm coming back to this stat here is that it is expected that we're going to see this happening in a different way in different parts of the world. So the way this is going to unfold in, let's say, Europe or America is presumably quite different from how it will happen in other parts in Asia or in Africa. But it really deals with management of scarce resources, with evolving population, with cities' needs, with the experience that citizens will actually have in cities, with commercial growth. I think we're seeing competition between different cities for both capital and talent unfolding, and there's a particular link to technology and economic growth with that as well. So some of the attributes that you might want to associate with the smart cities are here on the screen, and they are, well, generally quite positive attributes that we try to put in. So we're speaking about livable city, about happier citizens, about low carbon systems, about resilience and safe and healthy cities, things like that. So when Ordnance Survey got into the field of smart cities, which must have been about a couple of years ago, one of the first pieces of work we did was to work with the British Standards Institution on a city data survey report. And what we did there is to interview 30 cities around the world about the data needs that they would foresee for the future. And two interesting findings, among many others that came out, was that the notion of building information system and information about the infrastructure and buildings in the built environment were very much linked with smart cities. The second one, that GIS and geospatial data was important, but it was certainly seen as only one particular perspective. And I think that is a little bit of a call to actually move out of the niche of GIS to understand the needs for data, for location data in a city from a more holistic viewpoint. Last year we got involved in a project that the Open Geospatial Consortium is running as part of a European-funded Horizon 2020 project, which is called Espresso, and that aims at the standardization or the harmonization of smart city standards. And the project started with a view of a variety of different standards organizations and activities that are happening in this field, and to basically ask the question, well, how do cities navigate this maze of different standards, and how can they actually benefit from that? And one of the premises for this work is that in order to utilize data more effectively, standards will absolutely be needed in order to understand what others have done and how data can be multi-purposed and reused for a variety of different use cases. The project is structured in the way that it integrates a large number of participants that you can see here on the right-hand side, and we are now 1 year into this 2-year project, and a lot of work has been done on creating stakeholder communities, on defining and documenting use cases, giving practical advice to decision makers. A couple of pilots in cities have been started, and with a view for the second part of the project to really improve the standardization aspects and to make it clear which standards are available and how they can be used in a smart cities environment. So, as a quick summary, why smart? Well, it certainly has to do with tackling urban challenges. There is a need for standards, and this need extends to both data and services. And with Espresso as an example, I think we've seen that it's currently mainly in pilot mode. So we've seen projects popping up. We're involved in many more projects here in the UK as well as in other parts of the world, but we haven't seen kind of really big scale implementation necessarily in cities, despite the fact that some of these pilot activities and projects might be quite large. So data sharing and interoperability. Interoperability is really a key thing. It's important for making data available and utilizing data, getting more value from data in a country environment, in a city environment. And I should note that Ordnance Survey is a strategic member of the Open Geospatial Consortium, whose mission is really to make interoperability for geospatial data happen. And it's a little bit easier to talk about or to illustrate what interoperability is by talking about what happens when you don't have it. So interoperability is really about making sure that we can share maps on the web, that we can use data in different systems, and that we have a common language to speak about geospatial data, about location. As a quick example, the shared understanding of the data we deal with is actually quite important. So you'll probably all agree with me that, well, what you see on the screen, that looks like a lighthouse. But it really is a different thing to different people. So for somebody in aircraft, it's really a vertical obstruction. For somebody out on sea, it's a navigation beacon, and if you stand on the actual tower, it's an observation post. And that means the different meaning that comes from these different perspectives kind of needs to be captured and defined. And the standards that we have for geospatial data issued by the Open Geospatial Consortium as well as the ISO TC211 committee are really very valuable in defining the data and how we understand it. So what OGC offers, and where I think the geospatial marketplace is quite advanced, is that there are a whole host of standards available that aid the interoperability for both data and services. Now, if you look at data, you might have seen a map like this, which is the tube network in London, which is pretty much posted in every tube station in the city. But there's also another map which looks like this, which pretty much displays the same thing in a completely different way. So the information content of these maps is quite similar, but it's also really, really different. So for other data sets, what we actually need to know is what information is actually portrayed, how it's structured, how it's come together. And the difference here is obviously that we deal with a schematic map. On this map, whilst the one here is a more is kind of one that displays the station in their true positions. So describing data, defining data, and what's actually in it and how it can be used is a very, very important thing, which brings us to the point of the creation of data models that describe the structure of data, as well as the data specification, which goes into additional aspects of the data. For instance, how the data has been captured, how it can or should be portrayed, how it's updated, how it can be made available. One trend that we've observed in the geospatial world is that, well, perhaps 10, 20, 30 years ago, we were pretty much in a mode where individual large organizations were collecting data and then publishing this data, for instance, as a map. So you had national mapping agencies, Ordnance Survey, for example, who created or collected a lot of data and then published the data for everybody to use. But we have to realize that we moved into a mode in today's world by which basically everybody is collecting data, distributing data, and reusing data. And that has a particular implication on geospatial services, that we need to connect each other's services in order to use the data that's not only available from a few individual organizations, but that we have basically a marketplace for information with a lot of different players and providers as well as users. So one particular aspect that's quite interesting, where we're investing a lot of thoughts and effort at this point in time, is the delivery of content. And what the Open Geospatial Consortium does on an annual basis is to organize a big testbed activity in which standards are tested out in a number of use cases. And the one we are currently involved in is called Testbed 13, with a particular thread on streaming data and the 3D aspects of this. So if we look into the 3D aspects of this, out of the Open Geospatial Consortium alone, there's a host of standards available that you could utilize in order to deliver 3D content. That is the use of an OGC web feature service with a GML format, a web coverage service. There's a new 3D portrayal standard to be published, as well as a number of community standards which are just coming online called 3D Tiles and I3S. And we started the discussion that we really understand these different standards as a toolbox, but what we haven't had until recently was really to carry out practical work and to demonstrate and to give guidance on how these standards can actually be used in conjunction, or in which circumstances you would use one standard over another. So there will be a series of engineering reports to be published later this year. There will be a technical committee meeting of the OGC in Southampton in September this year, where we might get a preview of this work, with then a full publication towards the end of 2017. So what interoperability and standards in this area are really about is to reduce the choices in order to create more value. And you can understand this by really reducing the choices in order to make the reuse of data a lot easier. For that to happen, we need to do two things. We need to define the content, that's kind of what's in the box in your data set or in your view of the data, as well as an easy access mechanism which is needed. Now, moving into the foundation data sets and services, and we came up with quite a generic model for how geospatial information is typically used and plays out. And that goes along a value chain which is roughly to produce data, to share data, and to utilize data. In the use box, applications are obviously vital. This is where the value of the data falls out. Then on the left-hand side, data needs to be produced. But what we've been concentrating on in recent years is pretty much the share bit. And you can see this as an application of what we call spatial data infrastructures, where all of these items are important, but also smart cities initiatives as well as data platforms. And it's interesting to note that the share part basically falls into a very technical bit, which is all about the technical platform and architectures and the system that basically makes data available and allows sharing to happen, as well as the softer level of policy, governance, community, and standards, which we think is equally important. So the idea to utilize data, geospatial data, for multiple purposes is not necessarily new. This is a slide that's about 15 years old, where the vision was developed to put a data standard in place and then use it for a variety of different use cases, really ranging from simulators to tourism to urban planning, facility management, navigation, and so on. And this slide was really the starting point for the motivation of the development of a standard issued by the Open Geospatial Consortium called CityGML, which, well, is often seen as a standard for 3D because it allows you to depict data in 3D in a variety of levels of detail. But it's also really a standard for data integration in a city context, and that's quite relevant here. So if you look at the notion of foundation data sets, so which data sets might be important in a city or a country to have, you could look at it as a series of important registers, important kind of official, authoritative registers of information. And there's a suggestion that these might fall into the following categories. So addressing data is usually very handy and very versatile in order to describe location. Topography, in terms of a topographic map, describes the surface and what's basically there in the landscape. A register of land, perhaps together with who owns the land in the sense of a more traditional cadastre, is important. There's a transport aspect, there are the infrastructure network, and there are surfaces that have to do with height. But in addition to these registers, we are increasingly dealing with other types of data that is, well, a lot less structured than these registers. And that's data that's coming in from a whole host of sensors, imagery data, as well as other unstructured, semi-structured data that's published. And one of the challenges for the future for both the data and the data standards and services and the service standards is to link up the green bits you see here with the red bits on the bottom. When it comes to services that you might need, I think they roughly fall into three different categories. So access to data with an objective to display or extract data is certainly an important part, and is probably the area where most of the development has gone into in previous years. But also the analysis and processing of data is where we see services pop up, for instance, the web processing service issued by the Open Geospatial Consortium. But then there's this kind of new area for which should allow you to geo-enable, to add location to other data sets that don't necessarily come with a location. And that's really with a view to integrate information and to enrich information. A quick example, which is from the Future Cities pilot that we did with the OGC over the last year. Here you can see an example for data from different sources coming together in an end-user application, and that includes kind of attribute information, which you see color-coded here, which comes from a different source in the actual buildings, and the street information and the aerial imagery that you see. A few years ago, we did a project in the Kingdom of Bahrain where we created a very holistic spatial data infrastructure, which basically created, well, common integrating structure for all geospatial data to be present, or that was present in the kingdom, really ranging from land data, building data, to aeronautical and marine data. And we created a very detailed and formal description of the data itself, together with a complete data specification for all of these data themes. So describing the data is really quite important. So to summarize foundation and data services, really we need multiple access routes to define content. We need a geospatial framework that ideally should be standards-based in order to be future-proof and be quite independent from the rapid changes in technology that we're experiencing. And we need a data platform with geospatial functionality and tools, which may not necessarily be something that we can today call a geospatial information system or a GIS. So the last chapter is about a location-enabled data platform, and let me just start with the notion of the integration of geospatial data and BIM. So there was a fairly interesting article in the GIM International magazine recently that focused on, well, the notion of a 3D GIS and how data in the urban environment can be integrated. And the statement I pulled out here was that it was less about perhaps more traditional kind of survey-influenced attributes of data around the accuracy, but it was all about the semantic difference and divergence, the different meaning, the different paradigm from which data was created, and that interoperability, again, is the key word here, was seen as an important thing to achieve by basically fusing the knowledge that comes in from a geospatial perspective and from a construction and BIM perspective. In this area, two standards organizations, the Open Geospatial Consortium, which I've talked about, as well as Building Smart International, which is a standard organization looking after Open BIM building information models, have recently created a joint working group called the Integrated Digital Built Environment. And what we try to do in this working group is bring these two worlds of geospatial and BIM closer together in order to achieve better interoperability and integration of data. And that typically happens across this continuum of scale, where from the geospatial domain we are certainly more familiar with the kind of scales on a world, country, region, city level, while it's from a building information modeling perspective we come in more on a site building story and components level. And what we're trying to do is to exploit this overlap that you can see here in the middle. So in order to build a data platform for the urban environment, one of the ideas that we're dealing with is that there might be kind of two routes to get there. So one is to take geospatial data, to take this kind of view from above, from an airplane or photogrammetric sensor, for instance, and drive this into a bit more detail. But then there's this other idea coming out of the BIM domain, which is to say, well, we have very detailed information for individual buildings and parts of infrastructure, and we scale this up to a city level. And we feel that the answer will be somewhere in the middle, that in order to create a city data platform, that we basically need to combine both approaches and create and maintain and manage the data going forward. So last example I have for you today is the OGC Future Cities pilot, in which we explored 4 different use cases in 3 different cities in Europe, and had use cases around urban planning, the optimization of services, social deprivation, as well as flooding. And what we try to do in this Future Cities pilot is to demonstrate how geospatial standards on both data and services can be brought together in a future cities or smart cities context to solve real-world problems. And unfortunately, I don't have time to go into this into more detail, but a very nice video was produced, which you can find by just searching for Open Geospatial Consortium FCP1 video. So it's worth having a look at that. So before I come to an end, there's this idea of information integration, and what you see here is something that we've called the unseen road. So if you just look at this picture, you will certainly find out certain aspects about this particular road or this particular part of town. But it's only when you can integrate other types of information which you can't really see, about a road that's under construction, about resurfacing work that might start, about who actually maintains this particular pavement, the information that you can actually pull together becomes so much richer. And that is essentially what information integration is about. So, in summary, coming to an end, a location-enabled data platform is something that we perhaps need in order to publish and integrate data. It's something where the integration of static data with more dynamic or real-time data becomes more important, and coming back to this notion of the unseen road, where we can uncover hidden detail and increase the value and experience that we actually derive from data. And with that, we can bring geospatial data and services together.